All right, how is everyone doing today? Awesome, an audience that responds. I love that. So, do any of these statements sound familiar? Does the idea of emailing database credentials to developers, does that make you cringe? Right? The idea that you have to take down applications to rotate secrets, does that sound wrong? If that is true, then you are in the right session. This is SEC304. My name is Apurva Vasti. I am the product manager for AWS Secrets Manager. And in this session, I'll show how you can use Secrets Manager to manage the lifecycle of your secrets and address these issues that are not great. Now, for those of you who are unfamiliar with Secrets Manager, this is a service we launched in April of this year. This service makes it really easy to manage the lifecycle of your secrets. The service also enables you to follow best practices such as rotating secrets and encrypting your secrets. So if you're an IT admin who's responsible for storing and managing secrets, now you can do all of that from this one location. Do we have any IT admins in the crowd? Nice, we have a few. Security admins. If you're a security admin who's nice, I see a few hands, that's really nice. So if you're responsible for meeting the regulatory and compliance requirements, well, Secrets Manager makes it really easy to do that with capabilities such as rotating secrets automatically, as well as encrypting secrets by default. And finally, developers. Any developers in the house? Ooh, so many. Nice. As a developer, you can onboard to Secrets Manager so that you don't have to worry about managing secrets. AWS will do that for you while you focus on building fantastic applications. So over the next 20 minutes, I'll introduce you to the capabilities of Secrets Manager. I'll give you a peek behind the curtains to help you understand how this service functions so that you have a better understanding of the service as well as more confidence in using the service. Next, I'll use another 20 minutes to introduce you to things that you should be thinking about as you adopt Secrets Manager. I'll include pro tips that help you see around the corner and set up good practices so that you can manage your secrets at scale. Finally, we'll close with a demo. So does this sound like a good use of your time? All right, nice. I do have a bunch of yes-no questions in the second half of the presentation, so I hope you continue this enthusiasm. Now, before I dive into the capabilities of Secrets Manager, let me give you a brief overview of why we launched this service. As with any other AWS service, our story begins with customer feedback. We heard from customers that managing secrets is really important, but it's really, really hard. Does that sound familiar? Our customers also said that they like IAM roles, right? IAM roles are fantastic because they give you temporary AWS credentials automatically. So if you attach an IAM role to an EC2 instance, as the application owner, you can focus on building a fantastic application without worrying about how the application will communicate with all the other AWS resources. The role will automatically create short-term AWS credentials, deliver it to your EC2 instance, and then rotate these credentials multiple times every day. So secrets management is taken off the table. You don't have to worry about it. AWS does it for you. So with this feedback in mind, we figured, let's build Secrets Manager, which will enable customers to manage the lifecycle of all other secrets. So database credentials, SSH keys, OAuth tokens. Any of these credentials, you should be able to use Secrets Manager to store, distribute, and rotate automatically. In terms of capabilities, I'll call out 4 key capabilities. The first is Secrets Manager ensures that your secrets are secured. Second, it also enables you to tightly control who can do what with your secrets. Third, it enables you to rotate your secrets without impacting applications or developers. And finally, as with all other cloud services, this is a pay-as-you-go model. So there are no long-term contracts, licensing fees, operational costs, things like that. Now, I have a slide for each of these capabilities, so I'll go through that now. The underlying storage fabric for Secrets Manager offers an availability SLA of 99.999%. So what this means is you can be assured that your secrets will always be available. Secrets Manager encrypts your secrets by default, so you'll never end up in a situation where a secret was left unencrypted accidentally. These encryption keys live in your account, and you have full control over them. Once encrypted, you can retrieve these secrets either through a publicly accessible endpoint or through a VPC endpoint that's specific to only your organization. Secrets Manager also provides client-side caching libraries, so you can cache your secrets locally and securely so that you're not impacted by transient network issues and things like that. The service is compliant with HIPAA, and I'm happy to announce as of today, the service is also compliant with PCI and ISO. So the big takeaway with the storage story here is, once you store your secrets in Secrets Manager, you don't have to worry about your developers viewing or managing secrets. You have the tools to ensure that your secrets are not visible to your developers. Now, storing secrets is really easy. In a demo later on, I'll show how you can store a secret and retrieve a secret from the console. But if you were using the CLI or the SDK, you simply call the create secret command to call the secret, to create the secret, and to retrieve the secret, it's as simple as calling the get secret value command. So we spoke about storage. Let me now speak about access control. Secrets Manager offers a variety of tools that enable you to tightly control who can do what with your secrets. Of course, we offer IAM policies. Now, I'm sure you're already familiar. IAM policies are super fine-grained. So you can write a policy that's employee Bob can retrieve data, the test database whenever he wants. But if he wants the database credentials for the production database, he must come in from the corporate IT network, and he must provide a second factor of authentication. So those are the kinds of details that you can add in an IAM policy to get very fine-grained access control to your secrets. The other interesting piece around access control is resource-based policies. Are you guys familiar with the concept of resource-based policies? Can I get a show of hands? All right, that's about half the audience. So resource-based policies they're similar to key policies in KMS or bucket policies in S3. They act as another mechanism to control access to your secrets. The prototypical use case here would be cross-account access. So let's consider this scenario. Let's say a business partner requires SSH access to an EC2 instance to help troubleshoot. Well, you could email them the private key, but the private SSH key, but then you wouldn't have any control on who that key is forwarded to. On the other hand, you could store that key in Secrets Manager, attach a resource-based policy that allows a role in the business partner's account to retrieve the secret, and then when the task is over, you can rotate your SSH key. So the next thing I'll call out on this slide is tag-based access control. So Secrets Manager supports the ability to tag secrets, and this makes it really easy to organize your secrets and use them. Okay, let me give you an example to make this more relatable. Let's say you have a team called team equals Odin. This team needs a variety of secrets, SSH keys, OAuth tokens, database credentials, stuff like that. Well, you can store all of these in Secrets Manager, and for each secret, add the tag team equals Odin. After that, you can write one IAM policy that grants access to all secrets tagged team equals Odin. And now, with this one policy, all the team members can get access to all the secrets required by the team. Now, in the future, if the team adds more databases and has more database credentials, well, store them in Secrets Manager and give the appropriate tag, and that's it. You do not need to worry about updating IAM policies anymore because the policy is based off a tag that has already been put in place. Similarly, if a new employee joins the team, you simply attach this one policy to them, and they are good to go. They have access to all the secrets that they need to perform their job without you spending a lot of time figuring out the access control mechanisms and things like that. So with all of these tools, it becomes really easier to prevent your employees from using secrets that they shouldn't be using. Basically, this helps you reduce secret sprawl. Now, here's what a sample IAM policy could look like. This policy grants the ability to read in the action statement, in the action section, it grants the ability to retrieve the value of the secret. So the value is the actual SSH key or the actual username and password that you've stored in Secrets Manager. In the action section, you'll notice that I also grant the permissions to describe secret. This is powerful because you can use describe secret to read the metadata of the secret. Metadata such as what's the description of the secret? Is this secret set up for rotation? Are there any tags associated with the secret? If yes, what those tags are. So you can describe the secret to really understand what the secret is for and how it should be used. In the resource element, you'll notice that I restrict these permissions to a particular secret. That's important, right? You don't really want employees to have access to all your secrets. So you can go really fine-grained and define exactly which secrets they should be able to use and describe. Later on in this presentation, I talk about tag-based access control, and I show a sample policy that will enable you to grant these permissions, but at scale. If you're curious about IAM policies, I highly recommend session 316 on Tuesday. It's called IAM Policy Master, and that'll be super helpful in figuring out how to make the most of IAM policies. Okay, so we spoke about storing secrets, and we spoke about access control. The next key capability is the ability to rotate secrets. Now, with Secrets Manager, we offer built-in integration for rotating credentials for databases that are hosted on RDS. But if you have other kinds of secrets, you can store and rotate them too. You simply go to Secrets Manager, add the secret, and then write a custom Lambda function to meet whatever your rotation need is. Later on in the best practices section of this presentation, I'll talk about things to keep in mind when you set up rotation. The key point here is once you've stored a secret in Secrets Manager and you've set up automatic and safe rotation, you've essentially transformed a long-term secret into a short-term secret. So the database credential that used to live for years now becomes a credential that's rotated, let's say, every 30 days or every 7 days or even every day, transforming this long-term credential into effectively a short-term credential. And the way Secrets Manager makes all of this work is by using Lambda functions and supporting this concept called versions of secrets. So in the next few slides, I'll give you a peek behind the curtains, and I'll help you understand how Secrets Manager actually executes these rotations safely. In a typical scenario, if an application needs to retrieve data from a database, the application reaches out to Secrets Manager first. It retrieves the database credentials and then uses these credentials to retrieve data, right? Pretty straightforward. But now, if you choose to configure rotation, Secrets Manager will create a Lambda function in the same VPC as your target database. Now, based on the rotation frequency that you define, this rotation function will trigger a rotation. What this means is it'll create a new credential pair. It'll give this credential pair a label called AWS pending. It'll then store this credential pair in the database and run a variety of checks to ensure that this credential pair functions the way it should function. Now, throughout this entire process, if the application requires access to your database, the label that's the version of the secret that's labeled AWS current is still functional. So your application is not impacted. Your application continues to function the way it should function. Now, once Secrets Manager ensures that the new credential is behaving appropriately, it updates the version on this new credential to AWS current. And the previous version of the credential is labeled AWS previous. From this point onwards, if the application wants to retrieve data from the database, it reaches out to Secrets Manager and ends up getting the newer credential. So the previous version, the one that's now labeled AWS previous, that will become invalidated either immediately or at the next rotation. It depends on how you've chosen to rotate your secret. The last key capability that I'd like to call out today is the payment model. With Secrets Manager, there are no long-term contracts, licensing fees, operational expenses, things like that. It's all about paying for what you use. As far as pricing is concerned, there are two key attributes that I'd like to call out right here. The first is, when you rotate a secret, you pay for calling the rotation API. You don't pay for creating a new secret, because as I showed you previously, you haven't created a new secret. You just created a new version. So you are not paying an extra 40 cents for this new secret. Second, we support client-side caching libraries. In fact, we launched client-side caching for Java and JDBC drivers last week. And you can use these caching libraries to cache your secrets locally so that you make fewer API calls to Secrets Manager. So that's another mechanism to control the amount of API calls that are metered and built by Secrets Manager. Later in this presentation, I'll talk about practical considerations that you should keep in mind when you decide how frequently you should rotate a secret or how frequently you should retrieve a secret from Secrets Manager. OK, now that I've described the key capabilities of Secrets Manager, I'll run through a quick demo. The code will be available at this bit.ly link starting Thursday at 10 a.m. So in this demo, I use a CloudFormation template to create a public subnet where I place a Bastion host and a private subnet where I keep my database as well as my EC2 hosts. When I created the database, I also provided it a username and a password for the master credentials, and I also opted to set up rotation. So the rotation Lambda function lives in the same VPC as the database. So now I'll quickly switch gears, and I'll show you what all of this looks like from the console. All right, as I mentioned previously, I've created this database in a private subnet. So this database does not have, sorry. This database does not have internet connectivity. There is an endpoint, but it's not publicly accessible. I've also created a Bastion host in a publicly accessible subnet. So you see here, this is the IP address for this subnet, IP address for this host. And I have EC2 instances in the private subnet that are not accessible directly from the outside world. Okay, now what I'll do is I'll go to the Secrets Manager console. I'll store the credentials for this database in Secrets Manager, and then I'll trigger a rotation to programmatically rotate this credential. So to get started, I log into the Secrets Manager console. So here's what the flow looks like. I first select what type of secret this is. Well, this is for an RDS database, so I select the first option. I provide the username and the password. I choose to encrypt using the default encryption key. Later on, I'll talk about how to make the decision to use either the default key or a CMK. Next, I select which database this credential is for. I'll provide the secret an easy-to-remember name and a meaningful name. So and a description. I can also add tags. So I'll stick with the example of the team name. Next, I choose how frequently I want to rotate this credential. So I can set up automatic rotation. I choose the frequency. Since this is the master credential for the database, I choose the first option. So and now I just have to press the store button. I ended up storing this credential previously because this triggers a cloud, completing the rotation process triggers a CloudFormation template, which creates the rotation lambda in the same VPC as your resource and uses this rotation lambda to execute the rotation. I can show you what all of that looks like right here. Right, so these are all the steps that it had to take place for this process to work. So here's how you, so I just showed you how to store a database credential and set up rotation and what happens behind the scene. For the next few slides, I'm going to switch gears and talk about some practical considerations that you should keep in mind when you decide to use Secrets Manager. I'll also recommend best practices that will help set you up for success as you use Secrets Manager at scale. So there are 6 things that you need to keep in mind as you get started. First, how will you identify where your secrets are being used today, and what's your strategy for migrating them to Secrets Manager? Second, based on your security and compliance requirements, define how frequently you need to rotate your secrets. Third, once you've stored your secrets centrally, how do you retrieve them and how frequently? And this will depend on your network configuration as well as your application setup. Fourth, decide how will you manage permissions to store, retrieve, and rotate secrets. Fifth, plan on using unique secrets in every region and in every environment. And finally, decide how you will audit the use of secrets, as well as what is the type of activity that you want to monitor. So let's just walk through each of these. I do notice people taking pictures. All of these slides will be available at the end of this session, so probably by tomorrow morning. So I've already spoken about the benefits of removing plain text secrets. So let's just focus on how to get started. The first big decision is your account strategy. Do you store all secrets in one account? Or do you store secrets in multiple accounts? After that, you need to work with your application owners and administrators to identify where your secrets are being used today. This will be an iterative process. You will gradually find all your secrets. But one thing to sort of hasten this process is you can build tooling that helps migrate these secrets. So as soon as they're found, if you have the appropriate tooling such as CloudFormation templates or just regular scripts, you can move these to Secrets Manager to speed up the process. Now, here are some things to help you get started with moving your secrets over. Operate Secrets Manager in each AWS account. So don't choose to consolidate in a single account. Instead, for each application, manage the secrets in the same AWS account. And there are a couple of benefits to this approach. First, placing secrets in the same account as the resource helps you logically group everything that you need to make an application work. Second, accounts act as natural boundaries. So that reduces the blast radius should a secret be compromised. And finally, this makes it really easy to manage secrets at scale, because now what you can do is you can give the application owner full access to Secrets Manager within their AWS account so that they can quickly create and manage secrets, while you have the right monitoring and enforcement tools that ensure that these secrets are managed in accordance with your security policies and your compliance policies. Next, as you get started, set up conventions. Set up conventions for how a secret should be named. Set up conventions for when a secret should be rotated. Define upfront what the encryption mechanism should be. In the next few slides, I'll talk about, I'll give you a few options about these conventions and what the recommended practice is. And finally, sanity check the number of secrets. If you think you have 100,000 secrets, I bet you are overestimating. You need to rethink your idea of secrets. For a typical enterprise, I would expect a few thousand secrets. A startup would have a few dozen secrets. OK, so let's consider this scenario. I created a database. I provided the master user and password. I stored that in Secrets Manager. And when I stored the secret, I used the name Test Secrets Manager. What do you guys think? Is this a good practice or a poor practice? Oh, yeah, nice. That was an easy one, right? So use names that are meaningful. Use names that are hierarchical. And use descriptions. Use descriptions generously. In the description, add information such as who owns the secret, what is the secret for, who is responsible for managing the secret. In the long run, getting the description right and setting in place good naming practices will make it really easy to manage secrets at scale. So, for example, a developer can now look at the description of the secrets to identify which secret they need to make the application work. They can also now look at the description to identify who they should reach out to get access to that secret. So using the right description can go a very long way in building transparency and enabling management at scale. Okay, so for this example, I use a hierarchical name and a description. What do you all think? Good idea, poor idea? Well, I'm going to disagree on this one. Use tags. Tags are super valuable, especially when you want to manage secrets at scale. If you have 10 secrets, sure, you can work without tags, but as soon as you get to a few hundred secrets, tags will be invaluable. And here is how you enforce the practice of using tagging. You can add this statement to your sample, to your IAM policy, and what this statement does is it says, if you're creating a secret, you must provide a tag, and the tag should provide the team. So you can use various versions of this condition to meet your unique tagging requirements. Okay, let's talk about encryption. In this screenshot, I choose to encrypt using the encryption key. What do you all think? Good idea? Not so good idea? Bad. All right, I heard bad a couple of places. It depends. The default key is great because you don't have to manage additional AWS KMS permissions. Plus, Secrets Manager creates a unique encryption key for every account and for every region. So if you have secrets across accounts and across regions, they are all encrypted using their own encryption key. But you may have scenarios where you are required to use CMKs. You may have compliance needs that insist that you have CMKs. CMKs are also valuable for cross-account access. So if you have secrets that have to be retrieved across accounts, you have to use CMKs. Finally, CMKs act as another set of access control. So you can put policies on the CMK to control who can use the CMK to decrypt the secret. So it's another mechanism for controlling access. Okay, the next big thing that you need to think about is how do you rotate your secrets and when do you do that? As I mentioned previously, this will depend on your security and compliance requirements. But here are a few things to get you started. For existing applications, move their secrets over first and worry about rotation second. But if you're building newer applications, store the secret and set up rotation right from the get-go. Here are a few shortcuts to help you figure out your rotation strategy. The default frequency is 30 days on the console. It should work for most people, but check your compliance and security requirements to find out what this number should be. As I mentioned previously, when you rotate a secret, you're only paying for the rotation API and for the Lambda. You're not paying for a newer secret. So rotate your secrets actively. You don't have to be stingy about that because of cost. As I showed in the demo, or as I showed previously, to execute rotation, Secrets Manager creates Lambda functions. Now, these Lambda functions require the ability to communicate with the target resource, so the database, as well as Secrets Manager. So make sure you've set up the appropriate gateways. And you can make that easier by using VPC endpoints. VPC endpoints is the recommended practice because now your application, as well as the Lambda, can talk to the Secrets Manager without going through the publicly accessible internet. This rotation lambda is also responsible for creating the new credential pair. It does this by calling the getRandomPassword API. Now, by default, Secrets Manager will create the most complex password possible. But you may have scenarios where you want to use simpler passwords. So, for example, you may have a legacy application that does not support special characters in the password field. Well, in those scenarios, you can update the Lambda function to provide a parameter to exclude special characters when the getRandomPassword API is called. So think about your downstream applications and keep their requirements in mind as you define your Lambda functions. And finally, instead of creating a unique Lambda for rotating every secret, try to reuse Lambdas. That's just more scalable. All right. We'll quickly go through a few screenshots and talk about if this is a good practice or not. So I created a database, brand new database. I'm storing the database credentials. I choose to disable automatic rotation. Good practice, poor practice? All right. Set up rotation ASAP. So I decide to set up rotation. I set the frequency as 30 days. I choose to create a new Lambda versus reusing an existing Lambda. Now, this one's a trick question, so I'll not pose this as a question. Your decision depends on what the use case is. In general, it's easier to reuse existing Lambdas, and here's why. When you create a rotation Lambda, you also have to create an IAM role that's associated with the Lambda. So rotating requires certain IAM permissions also. In general, you should be very stingy with your IAM permissions. So one path forward is a very small group of employees have the ability to create these rotation Lambdas as well as the IAM roles, while a much larger group of employees gets the permissions to store secrets, as well as call these existing Lambdas to rotate secrets. Does that make sense? Also, it's just easier to manage a smaller number of Lambda functions. Now, when you configure rotation, you have two options. You can choose to use this secret to rotate, or you can choose to use a previously stored secret to rotate. Your decision would depend on what secret you're storing. If you're storing the master credentials for a database, use option 1. For any other credential, use option 2. All right, so once you've stored your secrets and you've set up rotation, you have to decide how you will retrieve these secrets. Now, retrieving secrets is just like accessing any other AWS resource. You require IAM permissions. So to get started, create IAM roles for your applications and give these roles appropriate permissions. In most scenarios, retrieving a secret once an hour is fine. You can also use the client-side caching libraries to just offload all of this management. If you use these libraries will retrieve the secret for you. They'll refresh the cache every hour. And if there are authentication failures, it'll reach out to Secrets Manager again and refresh the cache. So retrieving secrets becomes really easy if you're using one of these client-side caching libraries. We launched client-side caching support for Java and JDBC drivers last week. In future releases, we'll consider supporting client-side caching for Ruby, Go, and Python. If that's something of interest to you, just let me know. That'll help us prioritize our roadmap. For folks who build on serverless, this is really important. You should retrieve the secret outside the Lambda handler. When you do this, it allows you to cache the secret within the Lambda container, which in turn reduces the number of API calls that you have to make to Secrets Manager. So if you're using serverless, retrieve the secret outside the handler. And finally, if you decide that you do not need a secret anymore, I would recommend scheduling it for deletion instead of deleting it immediately. The rationale here is if it turns out that someone did need access to the secret, you can quickly go back and restore the secret and get the application or employee working again quickly. Now, this is just a sample which shows how easy it is to use the client-side caching library. So if you're using C3PO connection pooling with Spring, moving over to the client-side caching library is as simple as making a few changes and redeploying your application. All right. The next step is locking down permissions. So start by identifying who needs what access. I think that's obvious. Then define the IAM policies. And wherever required, use resource-based policies. That's typically for cross-account access. So here are a few pro tips. Very, very few people should have full access to Secrets Manager. You should be super stringent with that. You can be way more liberal with list secrets and describe secrets. As I mentioned previously, if you grant these abilities to your employees, it makes it easier for them to go find the right secret and then ask access to that secret, right? Makes it easier for your employees to be agile and operate quickly. Remember, as I mentioned previously, configuring rotation requires IAM permissions. So be very careful with who has to configure rotation. One way to mitigate, or one way to address this would be to separate responsibilities. Give a section of employees the permissions to store a secret and retrieve a secret, while give a smaller section of employees the ability to configure rotation. Also consider using tags. As I mentioned previously, tagging is super valuable when you're managing a larger number of secrets. And finally, cross-account access requires the use of CMKs. So that helps you decide if you need to grant additional permissions to create and decrypt using CMKs. All right, next step. Use unique secrets. Within Amazon, we require our teams to create and use unique secrets in every environment, in every AZ, in every region, in every account, right? The benefits of minimizing the blast radius are massive. This also actually makes it easier to recover and restart in DR scenarios. And it reduces the overhead of synchronizing secrets across multiple regions. So to get started, use CloudFormation or other tooling to provision secrets. The more you rely on automation, the easier it will be to follow consistent practices across accounts and to follow best practices such as creating unique secrets. And then once you've created unique secrets, require your applications to reach out to Secrets Manager from whichever regional endpoint the application is using. I often hear customers that we replicate our applications across regions for DR, so we want to replicate secrets. In the next slide, I'll show how you can replicate applications without the need to replicate secrets, right? You can still use unique secrets even if you are replicating applications and data across regions. So consider a typical scenario. Let's say you have an application that requires access to a database. Well, you can use CloudFormation along with Secrets Manager to create the database credentials that will allow your applications to talk to the database. That's step one. From this point onwards, if the application requires access, it simply reaches out to Secrets Manager, uses the getSecretValue command, and receives the database credential. which is in turn used to get whatever data the application needs, right? This is easy. Now, let's say you want to replicate your application as well as your data. Well, you can go ahead and do that, but in the new region, just run your automated CloudFormation script again. Run this script to create a new credential and store this credential in Secrets Manager. Now, in this new region, in the Ohio region, when the application needs access to the database, it reaches out to the regional endpoint of Secrets Manager. It'll receive a credential that's unique and that's valid only in this region, and it'll then use this credential to collect data. So you can replicate applications, you can copy data over, but you do not need to copy secrets over. Just use CloudFormation and other automation tools to create unique secrets. Right, finally, talking about auditing and monitoring the use of your secrets. If you want a quick glance at who's using Secrets Manager, you can simply use IAM Access Advisor. If you want more detailed records of who went in and who did what with Secrets Manager, well, use CloudTrail. Now, because CloudTrail integrates with the entire AWS ecosystem, it also gives you the ability to see how your secret was used once it was retrieved from Secrets Manager. So you can build an entire story. You can say, Bob retrieved the database credential from Secrets Manager, and then he went to the RDS instance and used this credential at time X. And next, if you want to monitor the use of your secrets, well, use CloudWatch events. Here are a few pro tips to keep in mind. I'll encourage you to monitor attempts to retrieve secrets that are scheduled for deletion. This is really important because if you've accidentally deleted something, and an application is still calling that secret or attempting to call that secret, then that means you have a broken application. So once you detect this, you can quickly restore the secret and get the application working again. You should also monitor access to high-value secrets. So production database credentials, SSH keys for your production instances, things like that. And remember, CloudTrail records all Secrets Manager API calls, right? So expect an increase in the size of your trails once you start using Secrets Manager. I figured I'll include some screen grabs to show what a typical CloudTrail record would look like, as well as how you can set up a monitoring alarm with CloudWatch events. Okay, so I introduced you to the capabilities of Secrets Manager. I walked you through the practical considerations of using Secrets Manager, and I included some pro tips that help you set up good practices. Finally, I'll run a demo which applies all of these good practices. So here's what I'm doing in this demo. I am using a CloudFormation template to create this infrastructure. I have public subnets that are accessible through the internet. I host Bastion hosts in these public subnets. I have private subnets where I store my databases, my operational EC2 instances, things like that. For private subnet 1, example host 1 has an IAM role that enables the host to retrieve a secret from Secrets Manager and use the secret to access the MySQL instance. In private subnet 2, the example host has permissions to list and describe secrets, but it does not have permissions to retrieve the secret value. And through all of this, I've set up a Lambda function which rotates this secret. So what I'll do next is I'll show you these resources, and then I'll run a few commands from the AWS CLI to show how to show what this looks like if you are within one of these hosts and retrieving the secret. Yeah, this is just a second factor authentication that we have on our corporate network. Okay, so here is the infrastructure that I've created for this demo. As I mentioned, we have a Bastion host. That's this one right here. Then I have two example EC2 hosts. The first one has permissions to retrieve secrets, while the second one only has permissions to list secrets and view details of secrets. I also have this CloudFormation template also creates a MySQL instance, and it calls Secrets Manager APIs to generate the instance as well as generate the username and password for this instance. This username and password is automatically stored in Secrets Manager under this name, and it's also configured for rotation. So let me show you what all of this looks like. So here's the database. It's not publicly accessible. The credentials for this database are available in Secrets Manager right here. So here's the name. Here are the details of the secret, such as how it was created, what tags to use, things like that. Scrolling down is the rotation configuration. And right here is the secret value. And I don't mind retrieving this value and showing it to you all right here, because as soon as this is done, I will trigger the rotation lambda to rotate the secret immediately. So as you can see, this points to the host that I showed you previously, and this uses the most complex password that this type of host supports. The rotation is triggered using this Lambda function, which is also created using the CloudFormation template, and the code will be available on Thursday. And here are the details of what this code does. Okay, so let me copy this password value over. And now I will close this and rotate the secret immediately. Now what this rotation does is it triggers this Lambda function to create a new credential pair, verify that the credential pair operates the way it should operate, and then update the label on this new credential pair to AWS current, so that that's the new secret that you see now. So let me connect to my EC2 host, and from the host, I'll retrieve this secret, and then I'll use this new rotated secret to connect to the MySQL instance. Right. I'll open PuTTY. I'll set up agent forwarding. I'm also using Pageant to provide the SSH key so that I don't have to provide it. I don't have to add it to PuTTY. I'll begin by SSHing to the Bastion host. From the Bastion host, I'll connect to the host in the private subnet. I've already set up MySQL on this host as well as configured the AWS CLI here. As I mentioned previously, I've attached a role to this instance, and the role has permissions to retrieve this particular secret. So I'll use from the AWS, I'll use the Secrets Manager get secret value command to retrieve the secret. All right? Now to make all of this a little more manageable, let me just call out what the password is. Now, as you can see, the password value right here is different from the password value that I had stored previously. So the rotation is now complete, and there is a new password that's available. You can also verify this from the console. So if I scroll down to secret value, I observe that the new password, that this is a new password. This is not the same as the previous password that was used here. OK, now I'll set up a few parameters so that it's easy for me to retrieve the host name, the username, and the password from the entire secret. So I copied over the password to this parameter. Next, I'll copy. You know what? Let me just echo and make sure this works. All right. Next, I copy over the username. And finally, I copy over the host. And now, with all the information that was retrieved programmatically, I can connect to the MySQL instance using the username, the password, and the host information that was stored in Secrets Manager. So this would be a good starting point for you to test how to use Secrets Manager. And then you can configure this CloudFormation template to meet your own needs. So for example, use different types of database instances, use different kinds of tags, things like that. All right, so that's it. I hope this session was useful. I hope you learned how to use Secrets Manager and things to keep in mind so that you can manage your secrets at scale. Thank you.